Hey guys, how you doing? This is Coach Scott, Purple Wave Chemistry again. Ooh, that just keeps on wanting to go. Let's see if I can do this. Right, there we go. Anyway, I had to focus. With our series on preparing you guys for pre-AP or AP chemistry, we're going to talk about differences in electronegativity when it comes to chemical bonds and how to look for it, right? Well, if you're on the test, they'll give you what the difference is. The key thing is you need to, I'm going to have to say it, but memorize it a little bit. Okay. As far as what these differences mean. Now, we know what difference is. It's where you subtract, right? Um, just to let you know what type of bond we're talking about. So it's pretty easy. Ionic bonds, ionic bonds, see if I can focus a little bit better. Ionic bonds are pretty much what? Metals and nonmetals, right? Metals and nonmetals. So there should be a big difference in electronegativity. Well, I got this nice little chart here, and this is what I'm going to use. You have it also. It's in your packet, right, for your summer packet. Let's look at one real quick. Let's look at sodium chloride, salt. We like that one. A metal and a nonmetal. So chlorine has an electronegativity of 3. Sodium has an electronegativity of 0.9. Well, let's see what the difference is. I don't know. All right, let's look at NaCl. So chlorine is 3. N is 3.0. Sodium, the electronegativity is 0.9. I could take my calculator out, but I shouldn't. I'm not going to. I can do it in my head. 3 minus 0.9 is, it's got a difference of 1, a delta of 2.1. All right. So for ionic bonds, they're going to have a difference greater than 2. I'm going to write these little rules down. The delta of electronegativity, or the difference of electronegativity, is going to be greater than 2. Or when you see a difference of electronegativity greater than 2.0, then it's going to be ionic. Okay? So, if it's less than 2, then it's going to be covalent of some sort. Okay, so let's look at these just a little bit and the different types of bonds. And we're looking now at those discrete covalent shearing of electrons, that type of deal. All right, so let's look at something like an OH bond. Okay, an OH bond. Then we're going to go down to covalent now. That's what we're dealing with. So let's look at an OH bond. Oxygen, and I'm looking at my chart here, has a difference of 3.5. Hydrogen 2.1. All right, got to remember that. 3.5. En, hydrogen 2.1. So let's get a difference, and that's what? 1.4. It has a delta of 1.4. All right, so anytime we have this would be polar, very polar covalent actually. So that means that the oxygen is going to hold on to that electron for the hydrogen more so than it's going to hang around with the hydrogen. But hydrogen's still sharing that electron, right? And if we're going to draw our little structure for it, 1, 2, 3, 4, 5, 6, 7, 8. All right, so one of those is being shared by hydrogen. Everybody's happy. So now, if we have a difference of electronegativity of 1.6. Yeah, no, we're not going to do that. We're going to say if it's less than 2, all right, and greater than 0.5, we're going to call that a polar covalent. Now the degrees, think about it. If it's closer to 2, it's very polar. If it's between a little less than 1 or closer to the 0.5, then it's going to be a little less polar. All right. They're going to share those electrons a little bit more. Okay. So now, let me get another color. Let's go with this one. So now, let's look at a nonpolar bond. We're going to say polar covalent. A nonpolar. Let's think of one. Let's look at carbon and hydrogen. Going by memory here. So carbon has got an electronegativity of 2.5. Hydrogen is 2.1. Let's write that down. A carbon-hydrogen bond. All right. So carbon is what, 2.5? And hydrogen is 2.1. So if I subtract that electronegativity, so we know, let's draw the little structure there for it. 1, 2. Didn't draw that one right, so that's just one there. All right, so carbon, hydrogen. We're looking at that bond. Okay, so each of these are discrete bonds also. We're looking at each one of those to see if each one is whether it's polar. You can have a polar and a nonpolar in the same molecule. All right, so if I subtract that, I'm going to get a delta of 0.4. All right, so that means that this carbon and this hydrogen is going to share that pair of electrons equally. So now we can say this. If we have a difference of electronegativity, all right, less than 5 or equal to 0.5, then for the most part we can say that this is a nonpolar covalent bond. Now, remember these are man-made little areas that we set ourselves up in. All right. In actuality, there's a little crossover, if you would. But if you use these for guidelines, you're going to be pretty good. Okay. Now, just for fun, let's look at this little sheet right here, which is in your packet. And I'll do one just to show what we're doing here, right? So it's looking for the difference between sulfur and hydrogen. All right, what type of bond is a sulfur-hydrogen type? Let's look. So sulfur has got electronegativity of 2.5. Hydrogen is 2.1. 2.1. Okay. So which one's more electronegative? It would, of course, be sulfur. Write down sulfur. And the value is 2.5. The less electronegative is hydrogen. Write it down. Hydrogen. And it is 2.1. So the difference is 2.5 minus 2.1, 0.4. So what type of bond is it? Well, using the sheet that we just drew, it's less than 0.5, so that would be a nonpolar covalent. just for fun, let's look at sulfur and cesium. Sulfur, again, is 2.5. Cesium is 0.7. So which is more electronegative? Of course, it would be the sulfur. Cesium is 0.7. The difference here is 1.8. Ooh. So, this we got to use a little bit of think here. Sulfur is a nonmetal. Cesium is a metal. Well, by definition, this is where we get a little crossover. This would either be a polar covalent or an ionic bond. If it's got two nonmetals, or a metal and a nonmetal, we're going to call it an ionic bond. Sulfur's here, cesium is here, so I'm going to call this a ionic bond because it has a metal and a nonmetal. And I'll be okay with that. Let's do one last one. Chlorine and bromine. Chlorine is right there. Bromine is right there. Which one's more electronegative? Well, they're the same. Just for fun, I'm going to say chlorine is. And my argument for that is that it's closer to fluorine than bromine. But they're pretty much equal. So it's 3.0. Bromine is 3.0. So your difference there would be 3.0 minus 3.0, 0. 0. So that is what? That is less than 0.5? Yes. Yes, it is. So I'm going to call this a nonpolar covalent. And what that means is that the chlorine-bromine bond, they're going to share those electrons pretty much the whole time. Okay? So anyway, this will get you going. There's several other questions on this polarity worksheet. Get this done. And if you have any questions, again, email me. We'll get together on Teams. All right? And other than that, guys, have a great summer. Hullabaloo, Knick.